When using AFNI, you may be interested to know what value for a t-statistic is associated with what p-value, and what p-value is associated with what t-statistic. We can find this out using a command called CDF, or cumulative distribution function. All it needs is the type of test that's been done and whether you want to convert from a t-value to a p-statistic or the other way around. So all we need, let's say we want to convert a t-value to a p-value, and it is an FITT or t-statistic. It stands for functional image t-test. And lastly, we give the actual t-statistic, so let's say 3.5, and then the degrees of freedom, let's say 20. So in this case, the associated p-value is going to be 0.002, roughly. If we wanted to do the converse, we could do CDF-P2T. Again, it is a t-test, and then give it the p-value, let's say 0.001, and the degrees of freedom, let's say 20. Meaning we would require a t-statistic of about 3.8 or greater to reach that p threshold. Now, if you want to know what degrees of freedom you need to use, you can use 3D info on your statistical data set. Now, go up to any of these t-statistics, so for example, a t-stat associated with a regressor called left, and then look at the stat code. It's a t-test, and the stat par, which is the degrees of freedom. In this case, 1160. What this means is there is 1160 degrees of freedom. And degrees of freedom is calculated as the number of time points minus the number of regressors in your model. So in this case, I had 5 runs. Each was 240 TRs, or time points. And so 5 times 240 is 1,200 data points, or degrees of freedom. Now, obviously, there must have been 40 regressors in our model to get this degrees of freedom of 1,160. So to see this, you can open up one of your JPEGs, your X matrix. So if you can use AIV followed by the JPEG, you should see something like this, which is your full design matrix. Okay, so notice that for each run, there are 5 regressors to account for any sort of drift. So in this case, the runs are long enough to merit 5 different trends. So not going to get too far into them, but a constant, linear, quadratic, cubic, and so on, increasing as your number of time points increases. So there were 5 of these for each run. There are 5 runs, that's 25 right there. I had 9 actual regressors of interest, 3, 4, 5, 6, 7, 8, 9. That brings us up to 34. And then lastly, I had 6 motion regressors to account for any sort of head motion. If you recall, the roll, pitch, yaw, and also any rotations and angles. So 1, 2, 3, 4, 5, 6, that brings us up to 40 regressors, or 40 columns in our design matrix. 1,200 minus 40 is 1,160, bringing us to the number of time points or degrees of freedom for that statistical data set. Now recall that this is only one subject, so we're only using degrees of freedom based on time points for that one subject. If we're using degrees of freedom for a group level analysis, it would be the number of subjects minus 1. So if you have 15 subjects, then the degrees of freedom would be 15 minus 1, or 14 for a t-test. Be aware that if you're using this to calculate a p-threshold based on a t-statistic and an associated degrees of freedom, the degrees of freedom can be misleading because not all of your time points are independent. There's a certain amount of correlation in your time series, or temporal autocorrelation. This can inflate the number of data points and therefore your degrees of freedom. So just be aware of that when you're using this tool.